Good afternoon, morning, guys. Today we're going to perform operation on complex numbers by adding, subtracting, and multiplying. You've already done this topic without even realizing it, so this should be a breeze for you today. So take a second. This is posted on Google Classroom under classwork. Number 2, operations with complex numbers. This PDF is exactly what we'll be doing today in class. So take a minute, pause the video, do these 2 questions out, and I'll do that after the pause. So for the first question, find the value of this. Anything squared is probably a good thing to start with. So let's square it first. 5 times 5 is 25. I to the third times I to the third is I to the 6th power. I to the 6th power is not okay, so you either have to go through your powers of I, going 0, 1, 2, 3, 4, and so on, or using your calculator, or dividing it by 4. I'm going to divide by 4 because I think that's the easiest way. 6 divided by 4 is 1.5. This 0.5 relates to I squared. So we have 25 I squared. I squared is not allowed on our test or anything, so I squared needs to be then put back in the calculator and know that it's negative 1. So you have 25 times negative 1, which is negative 25. Super easy, no big deals. That's exactly what we went over last class. So if you're having trouble, maybe it's time to go back to the first video and help you out with that, but that's up to you. Find the sum. Sum means add. Well, you can't add these up. If you want to do GCF and plot I to the 5th, be my guest, but you'll be even more confused. So instead, let's say, what is I to the 9th power equal to? Well, I to the 9th power, if we took this, we would do 9 divided by 4. This would be 2 with 0.25 left. 0.25 tells you this is really I. The remainder of 0.25 means a power of 1, and that's just I. So this is just saying 5I plus something. I to the 5th is equal to 5 divided by 4 is equal to 1.25. 0.25 points as an I power as well. And we have that right there. So 5I plus 1I would be 6I. Do not square it. You're adding like terms. If those are x's, it would be 5x plus 1x equals 6x. That should do now for today. Nice and easy. If you need to, pause it and look it over again. If not, let's talk about what we're doing today. A complex number is any number that can be written in the form a plus bi. Remember, imaginary unit. Where a and b are real numbers and I is an imaginary unit. A complex number is a number a or a pure imaginary number bi or the sum of both. Note, these examples of complex numbers can be written in standard form a, which would be like a number, plus or minus, doesn't actually matter, a number with the letter I next to it. Kind of weird, but 0i is complex, but it's 0 times something is 0, so you wouldn't really write that. So negative 5 would be your answer. So, simplify a radical negative 25 and write your answer in simplest a plus bi form. This is a number plus a number with the letter I. If there's no number, a great substitute for no number is the number 0. Simplify this. So we've gone over this. See a negative inside a radical. Make your life easy. Stop there, you're going to lose a point. Well, this question, you lose 2 points. You need to simplify radical 25. That's a perfect square. So it's going to be 5 with a circle. So now we have 5i. But you're missing something. A plus bi. This is just bi. So this needs to be 0 plus 5i. On a multiple choice, if you saw that, that had to be the right answer. On a part 2, if you forgot this piece, you probably might lose a point, but not necessarily. So 5i would be mostly acceptable answer and 99.9% of the time. So write the following, write the following numbers in standard a plus bi form. Well, this needs to be a number plus a number I. This is a number plus nothing. So we got to fix that. A number plus nothing would be 0i. We need something plus bi. So a something plus nothing, which just sounds silly, but We need something here that has no value, plus 15i. And this guy's already good to go. So this is the multiple choice question, which I'm assuming it probably was. It probably was meant to say which of the following is in standard form. So letter C would have been the only one in standard form. And I'll do adding, you do multiplying?
Sure.
Okay. When adding and subtracting complex numbers, add like terms. Adding like terms mean the things that look the same, things with letters, things without letters. So find the sum of the real components. These are normal numbers. Normal numbers, the numbers that are by themselves with no letters next to it. Find the sum of the imaginary components. These components with an I after them. Rules for combine. We always give you this weird math thing that doesn't make a lot of sense, but this is the formula that we're using to make sure we understand what we're doing. If we had a really easy example, we would add the C and the A first. Well, C and A are just the numbers 2 and 4, so this would be 2 plus 4. Then we would add the B and D thing, the things that are in front of the I's. This would be 3 plus 6. And the letter I would just show up in the back. This is going to be 6 plus 9i. Wow, that was easy. Give that guy a try. Pause your video, try that out, use my example to help you out. 7 plus 5i plus 8 minus 3i. Give you a minute. Okay, we're going to use the same idea. So if you didn't pause your video, you're cheating. You are going to add the numbers in front first. The numbers in front are 7 and 8. So just using those, we have 7 and 8. If you want to do the parenthesis thing, be my guest. But you know 7 plus 8 is 15. We'll leave it as 15. 5i plus negative 3i. Well, 5i plus negative 3i is really 5i minus 3i, which would be plus 2i. Wow, that was tough. Just take your time, go slow, use your calculator with the numbers and adding if you need to. You plug this in to get the right answer? Calculator?
I think so.
If you plug this in your calculator, you probably will get the right answer. Let's take a look. So if you do get the right answer, that might help us out. So we'll do parentheses.
I have to be in the right mode.
Correct. So let's see what happens. So it'll be 7 plus 5i plus parentheses 8 minus 3i. Let's see what we get.
It's gonna work.
Yay, look at that. We don't have to do math anymore. But don't do that. That's bad. Plugging in the calculator is a great way to check your work on a Regents question or a non-multiple choice question. If I say show work and you just give me this, you're losing like 80% of your credit. So do work. On the Regents, if you just wrote this, you would lose exactly half your credit. And that would be really unfortunate. Goes to 64, still summer school. Pause your video, take a second, express the sum of that in A plus BI form. So you're pausing your video. And welcome back. We are going over how to find the sum of this. So let's rewrite it the way we had on the last page, which might help us out. So if there's anything to simplify, I would suggest doing that first. Well, radical negative, anytime you see radical negative, you stop and you fix it. This is not okay. This needs to be I radical 64. Well, radical 64 we know is 8, so this really should be 3 plus 8i. Is that any harder than the last page? No, it's just putting all the stuff we've been learning together. Right here, bad again. I radical 25. We should know that radical 25 is not okay. You need to write it as 5. Now combine your like terms. The numbers in front are both numbers, so 3 plus 10 is 13. (8i) minus 5i is plus 3i. And like I showed you earlier, you can plug in your calculator, but don't be a loser. Do your first, make sure you get the right answer, then check your work with the calculator. Someday in life, you're not going to have a calculator, but probably never true. All right, so Mrs. Worland's going to finish up with some multiplying.
All right, so for multiplying complex numbers, what's good is that it's the same exact way as multiplying two binomial expressions. And how do we multiply two binomial expressions? Our box method. If you are comfortable and familiar with FOIL, by all means, please do that. But we did everything with the box method before, so let's be consistent, and I'll just teach it that way. So the big thing to know is when you are multiplying your complex numbers, make sure you always express your answer in simplest a plus bi complex form. So I always want to simplify it at the end. So for example, we have 2 plus 3i times 4 plus 5i. All right, we'll start out by doing our box the same way we always do. All right, we have our 2 plus 3i and our 4 plus 5i. All right, we're going to go ahead and fill in the boxes. We got 2 times 4 is equal to 8. We've got 3i times 4 is equal to 12i. You have 2 times 5i is equal to 10i. And at the very end, we have 3i times 5i. Well, 3 times 5 is 15, and I times I is I squared. We'll talk about that I squared in a minute, okay? But we've got our 8 plus 12i plus 10i, and then plus this 15i squared at the end, okay? Can't do anything with this 8 just yet. We do know that we can combine these two terms in the middle, this 12i and this 10i, to get our 22i. But now this 15i squared, we spoke about already what I squared is. And we know that I squared is equal to negative 1. Right? I spoke about this in the previous lesson about how important that is to remember, that I squared is equal to negative 1. I squared is equal to negative 1. So anytime we see an I squared, we're going to substitute in a negative 1. So really, that's plus 15 times negative 1. And 15 times negative 1 is just negative 15. And oh, look, you've got 8. Let me rewrite this. 8 plus 22i minus 15. So what are our like terms here? Whoops. Our like terms are 8 and negative 15. We subtract them and you get your negative 7 plus 22i. So that is your final answer, and it is written in standard A plus BI form. Always remember to put your answer in that standard form, okay? There we go, 4th time's the charm. All right, so again, you want to make sure that you always replace your I squareds with negative 1. Anytime you're working with multiplying complex numbers, you're always going to have a term that has an I squared in it. So you must remember to replace that I squared with the negative 1, and then put your final answer in A plus BI form, okay? That's it? There's no other example? I guess not. All right, what about turning an imaginary number into a real number? Well, in our radicals unit, we learned how to rationalize a number by turning it from an irrational number into a rational number. And there was a point we spoke about something called a conjugate. And if you remember, a conjugate is just when you negate the second term of the binomial, meaning you change the sign in the middle. So the conjugate of 4 plus 2i is 4 minus 2i. Right? In general form, we say the conjugate of A plus BI is A minus BI. So notice that only the sign of that BI changed. We didn't change that A sign at all. So to write the conjugate of 3 minus I, right, just like when we worked with radicals, we're going to leave that 3 alone. Do not change that first sign. You're only going to change the sign in the middle, and it would just become 3 plus I. So take a minute, pause it, and see if you could do B, C, and D. Okay, so negative 2 plus 5i, the conjugate of that will be negative 2 minus 5i. That should not have been a problem. For C and D, I can understand if you're a little bit confused. But the way to make this really make sense is, well, this isn't in A plus BI form. Right now, it's just in I form, or BI form. So this is really equal to 0 plus I. And the conjugate of 0 plus I is just going to be 0 minus I, or negative I, because it doesn't say to write it in standard form here. It just says write the conjugate. So the conjugate of I is going to be negative I. So similarly, the conjugate of negative I, we're saying, should be equal to just I, because we can rewrite this as 0 minus I, which has the conjugate of 0 plus I, or just I. All right, so that should be easy. We did conjugates already. Conjugates, very simple, straightforward topic, okay? So let's go over some examples of multiplying. All right, this says multiply 2 plus 3i by its conjugate. I will start this off for you, right? Because right now we're only given one binomial to multiply. It's 2 plus 3i. But you need to multiply it by its conjugate. So what is its conjugate? Hopefully you're all screaming, oh, that's 2 minus 3i. And I say, good. So pause it. Take a minute. Multiply this. See if you can think back to when we did multiplying conjugates with radicals, and see if you can find a shortcut for this. So pause it for a second. Try it out. All right, good. So hopefully you went through this, you multiplied it out, and you saw that the same shortcut when multiplying conjugates with radicals holds true here as well. Right? We have 2 plus 3i times 2 minus 3i. If we were to go through the whole box method here, 2 times 2 is 4, 3i times 2 is 6i, negative 3i times 2 is negative 6i, and finally at the end, we've got our negative 9i squared. So what's the shortcut? Well, the shortcut is these will always cancel each other out. So you don't have to do the whole box method. You could just do the first times the first and the last times the last. And it's just going to become 4 minus 9i squared. Well, wait a minute. What is I squared? I squared is equal to negative 1. So it's really just 4 minus 9 times negative 1, which becomes 4 plus 9, which is equal to 13. Right? Did it say to write our answer in standard form? No. What if it did say to write our answer in standard a plus bi form? This would be 13 plus 0i. If it says to write it in that form, make sure you do, okay? All right, so now we're going to pause it, and I want you to go through the rest of these problems. You have numbers 1, 2, 3, 4, 5. I think that was it. All right, go work out those problems, and we'll put the answers on, and unpause it. We'll go over the answers.
I'm going to leave it for a second.
What's up?
I'm going to put them up in a sec.
Yeah.
I'm scared if I pause it, something might happen.
Yeah, no.
So you guys are paused. You should not be watching this yet. Quick work shown there for you and the answer. Box method, that's what you should have got out of that. I think that is 83 plus 39i. And the last guy came out as 12 minus 16i minus 9i plus 12i squared. This came out as just, there we go.
Pen, what'd you do? Whoop.
Natural products.
Yeah. All right, so for number 4, it says simplify 2 plus 5i squared. This is just going to be 2 plus 5i times 2 plus 5i. Go ahead and multiply, box it up, and you get negative 21 plus 20i. Negative 21 plus 20i. And for the last one, you just have to distribute this I, 8 plus 8i minus I squared. And when you do that, you get 9 plus 8i. All right? If you have any questions, please let one of us know. Don't be shy. Ask us. We understand this is a strange way for you to learn, a strange way for us to teach as well.
Next time we see you, we're reviewing for a quiz. So today's Monday, Tuesday. We'll be seeing you Wednesday and Thursday, then Friday. And when we get back at the Martin Luther King Tuesday, will be a full period quiz. Have a good day, guys. We will see you next time.
Bye, guys.